In this video, I'm going to discuss areas of similar shapes. This is very related to what I discussed last time, which is basically similar shapes and properties of similar shapes. So before I proceed, I just want to remind you about what a scale factor is and the relationship between a scale factor and an enlarged shape and the original shape. So basically, scale factor is the ratio of lengths. So ratio of lengths is also called a scale factor. And this is basically the length on the enlarged shape. So length on the enlarged shape divided by the length. In fact, it has to be a corresponding length. So corresponding length um, on the original shape. So on the original shape. So when a shape is enlarged, it will always be the original shape. Like in this case, in example 1, A is the original shape. And the, the information that you're provided with here is that shape A dash is an enlargement of shape A. Okay? And let's look at the corresponding lengths in these two shapes. So from here to here is 1 unit, and that will be 2 units. And also, if we look at the sides, that is 4 units, and that is 8 units. So you can be able to find the ratio of the sides of these rectangles. So ratio of sides will be equal to the length of the enlarged shape, which in this case happens to be 2, over the length of the original shape, which is 1. So the ratio of the sides is 2. And what we want to find out is the relationship between the ratio of the sides and the ratio of the areas. So let's look at the areas of these two rectangles. So the area of this one here, so the area for this is 4 units, and the area for this is 2 multiplied by 8. Actually, this is 4 multiplied by 1, just in case you want to. So that's for 2 multiplied by 8, which is 16. So the area of the other rectangle is 16. So the ratio of the areas, so the ratio of the areas will be equal to 16 over 4, which is just equal to 4. Now, one thing that you may notice here is that basically, if you square the ratio of the sides, that means 2 squared, you end up with the ratio of the areas, which is 4. So, note that uh, so if you have, if you square the ratio of the sides, so ratio of sides squared, what that gives us is the ratio of the areas. Just like I said, 2 squared gives you 4. So what we want to find out is that, is this relationship true for all similar shapes? Yeah, so by working example 1, 2, and 3, we want to find out if this relationship is always true. Yeah. Okay, so example 2. Again, if we look at the sides of these two rectangles, so that is 4 and that is 12. Here we have 6 and here we have 2. Let's just go ahead and find out. Well, let's start with the ratio of the sides. So the ratio of the sides, um, so, oops, over here. So the ratio of the sides, ratio of the sides will be equal to, um, again, remember what I said in the beginning, that will be um, the length of the large shape of the corresponding length of the original shape. So that will be 6 over 2, which is 3. And then to find the ratio of their areas, we need to find the corresponding areas. So area for this will be equal to 2 multiplied by 4, which is 8. And the area for this will be equal to 6 multiplied by 12, which is 72. So we can go ahead and find the ratio of the areas. So the ratio of the areas will be equal to basically 72 divided by 8, which is equal to 9. And again, if you look at these two, you can notice that the ratio of the sides, okay, we can see that the ratio of the sides squared will be equal to the ratio of the areas. All right, and it's the same thing that we noticed here as well. By looking at these two guys, we notice that this statement here is true. Yeah, and from example 2, we can also notice that that statement is true. All right, let's look at example 3 before we can conclude. So in example 3, we have triangles, and the height for this triangle here is 2. The height for this is 5. The base here is 4, and the base here is 10. So the ratio of the sides, so ratio of the sides will be equal to 5 over 2, which is just 2.5. Now let's find the areas of these two guys. So the area for that, we know that the area of a triangle is base multiplied by height divided by 2. So this will just be equal to 4. And the area for this will be base multiplied by height divided by 2, which will be equal to 25. So the ratio for of areas for these two triangles will be equal to 25 divided by 4, which is 6.25. Now again, if you notice, 2.5 squared is 6.25. So we can generalize and say that, again, it follows that if you have any two similar shapes, yeah, uh, the ratio of the sides squared will be equal to the ratio of their areas. And this is always true, as you've seen from example 1, 2, and 3.